Hey, John from RBJ Racing. It's been a while since I made a video, so I figured I would just make one up to demonstrate my system. I have a few other videos out there you can watch if you look around for them. Just basically what I'm going to show you is my system that I developed for doing seat and guide work, surfacing manifolds and whatever you can mount to this thing and do whatever you need to do to it. I'm going to show you a cylinder head work on this one, demonstrate how you can cut seats with this, with the efficiency of a seat and guide machine and the accuracy of the best machine out there. Basically what you would get if you were to buy the whole system, and you can buy each individual component or the whole system, is a rollover fixture. It's very simple, very rigid, 2-inch round bar, 1-inch thick aluminum plate. To adjust it, you loosen up the ends and you can roll it this way, and to adjust it up and down you loosen up the ends here and you can adjust it up and down. Digital level is accurate to a 10,000ths of an inch. So basically this is it. You get a digital display, you get a tilt sensor that's attached to it via an electric cord. It's a T-shaped top, and whatever way that T is facing is the axis you're going to be adjusting on. Basically what this is, I guess in its simplest explanation, is a very fast and accurate place finder. So what you're going to do is you're going to find level, you're going to put a cylinder head up there, with a pilot in the, pick any guide. You're going to find your rock over, or your highest point on that guide with a dial test indicator. You're going to sweep the guide on the X and the Y axis until you dial it into your quill. And once you have that pilot dial it into your quill, so when you sweep it, you're getting a zero deflection from top to bottom on the X and Y axis. Once you have that, then you're going to set your dial indicator on the X in the X direction and see what number it reads. Write that down. You're going to turn it to the Y axis, see what number it reads, write that number down. So now what you have is you've established a mechanical stick out with your dial test indicator, and now that you've set your digital level on the X and Y, you recorded those numbers, now to get you back to that mechanical established zero, we'll call it, on the X and Y, all you have to do is hit your numbers on the put your tilt sensor on wherever you are, any pilot, hit that number, 2500, whatever the number is. And you'll be within a tenth, 0 to a couple tenths of where you initially set it up with the dial test indicator. So that's how you level off. Once you get your established numbers, then you don't need a dial test indicator anymore, you're done. You use the digital level, you just hit your number on the X. When I say hit your number, whatever display number, this one is for my setup here, the x-axis is 2.457, and it actually is in between 5, 7, and 8, so it'll go 5, 7, 8, 7, 8, 7, 8, 2.457, but then the 7 will flicker from 7 to 8. So that's actually a setting, because I can move it a little more and it'll go 8, I can move it a little less, it'll go 7, it'll stick the number. And it's a little different. It's 2.459, 5960. 5960 is what for this particular setup. And then the center finder. So that's what you do. You put the head up there. You put a pilot in there. You level it off, and then to find center. So there's no tool changes with this setup. You got your ball head driver in your quill, and you level off with that. And then to find center, you're going to put your center finder up here. It's what I made this too. I was using a coaxial dial indicator, and I just wanted a better way, so I came up with this. Basically hooks to your pilot. Same thing. It's a V slot with a set. Both of these, the base, it's a V slot with a set screw in the back, brass set screw. So you put this on your pilot. You bring your socket down, your driver down in between. What you're going to do though is you just like the digital level, you're going to establish a mechanical center. You're going to find center with an articulating arm and a dial test indicator, or if you have a really good coaxial dial indicator, you know it centers very accurately. You can just center up with a coaxial dial indicator, stick this on your pilot, bring your socket down in there into the hole, set your dial indicator 0 to about 10th thou preload on the X and the Y, 0 them out. So then from there on out, after you level off, you bring your socket down in the middle of it, you move your X to 0, you move your Y to 0 on the dial indicators, you're on 0. And you're on center. It's a center that was established mechanically, and it's basically, again, it's a very accurate place finder, fast and accurate place finder. So with this whole setup, I mean, you can cut seats just as quick and easy and accurately as, like I said, the best thing out there. It's not as fast as a Surrey or something like that. It's every bit as fast as a VGS 20 or something similar to that, and much more accurate. I've never had good luck with getting consistent seat concentricity with VGS. It just, I don't know, it's just never worked out that well for me. So I'll give you a quick demonstration. What I do is I usually mount the exhaust side to the head plate. You could put the intake side to the head plate whatever way you want to do it. I'm used to doing the exhaust side to the head plate, and that's what I do. So I have a couple studs screwed in on the ends of the head. It's a 1/2 inch slot. I give you a 1/2 inch. In this particular case, it's 5/16. So I give you 1/2 to 5/16 for this. You're going to get 5/16. You're going to get 8mm 125, and you're going to get 3/8 studs. 3/8 has, of course, a different spacer. 3/8 to 1/2. So what it does is it just takes up, like I said, 1/2 inch slots. It just takes up the space, and it makes it a little easier. So you screw the studs into the exhaust side of the head. You put your spacers on there. You got a couple big washers for the back side with a nut on each one, and basically you just put it up in the fixture, a washer and a nut. This particular head is an AMC V8 head. It's just an old head. It's shot blasted and cleaned. It's got an old 3/8 guide in there from who knows what. I found a 3/8 valve. It's a 2025 out of the factory. I found a 3/8 stem 202 valve. I never run 3/8 stuff in these. I always change them to bronze guides in 11-30 seconds. So I just got a used valve I found. This is a 30-degree seat. I'm going to put a cut of 45 on it. So the cylinder head's up there, just that easy. You get a stand. You're going to get a support stand with a couple different threaded rods. You can use it's got some extension. I make them longer so you have some reach when you do, say, if you're going to do valve guides. You're going to have the intake side mounted, and the head's going to be facing down, and it gets kind of low to the table. Now this particular setup, I have 4 inches worth of riser. This fixture comes with 1-inch risers. So you're going to be low to the deck. I got room because I got a 6-inch riser on my mill, and I could put a block up here, like I said, so I got more riser on mine. You're going to get a 1-inch riser on yours. So you're going to need a low profile, extended reach stand with the setup. You can use it this way if you need more. You can turn it this way also and use it that way. And then you really got, you can get it pretty tight to the mill. So it's just basically going to support it and make your adjustment on the Y. So I'm going to leave it loose for now. So I already cut one seat here, I got everything set up. I guess a little bit about my mill. It's a 10 by 54 table, 3 horsepower Enco mill. I got a power drawbar. I got a variable frequency drive on it with a removable faceplate, so I could turn it on and off right here. I can adjust the frequency here, which adjusts the speed. I can underdrive it or overdrive it a little bit, which is nice because this thing turns down about 70 RPMs, but with the underdrive and the frequency drive, I can actually turn it down. Well, this is like 15 hertz. I don't know if you can see that or not, but it's turning pretty slow. I don't even know what it is, 35 RPMs maybe, or something like that. You can turn it down, so that's nice. It helps you avoid chatter. If you don't have that and you do get some chatter, one thing I found is you can take a little bit of rubbing alcohol. I have a spray bottle with some just clear rubbing alcohol. You can actually wet the seat with some clear rubbing alcohol, and it's enough lubricity where it seems to help you with the chatter, and it dries up. Because it's rubbing alcohol, it just dries right up, doesn't leave a mess like oil. So if you don't have that, that's, I guess, a little tip for you. I got a Goodson ball head driver, and I set this thing up with a Goodson micrometer for setting up the 202, like I said. You get bounce spring and a support, just like you would on a seat and guide machine. This is a Goodson ball head driver. It's a three-quarter straight shank with the standard driver. You're going to want to check everything. Another thing too, I guess one of the another advantage of this system with the digital level is your mill might have some, you're wearing it like this. This is an older mill, so it has a little bit of table tip. You send the thing one way or the other, you're going to get some table tip, whatever, a couple thou. If it's real bad, you might get 2, 3, 4 thou or whatever. So if you level this thing off, center it over the knee with a bubble level, and then you send it out, now it tips. I mean, and you level it off with a bubble level, you're not going to be level. So, but with the digital level, it doesn't matter where you are. You can have the machine doesn't even have to be level, because all it does is you've established a mechanical stick out, a mechanical zero on your X and Y, and that thing takes you back to that mechanical stick out. It's independent of position, I guess. It doesn't have to be level to the world like a bubble. So this thing. So I guess I said that to say this. What some guys can do, I guess one of the advantages to this is not only that you can level off no matter where your table's at. It doesn't matter because you're bringing the workpiece to it. And you're not leveling off to the world, and hopefully your table or what is maintains a level to the world. So with this thing, some guys they use it to mill for surfacing and valve jobs. So what they'll do is they'll put a little lead angle, whatever way they're going to cut for surfacing, they'll put a little lead angle on their x-axis, and then they'll dial in their digital level. So what they can do then is they can do their valve job, because again, it doesn't matter, it doesn't have to be level. All that does is bring you back to your original stick out. Do your valve job, then what they do is they'll level the cylinder head off with a dial indicator. They'll sweep it, level it off, resurface it, and then they can flip it up. And they don't have to tip the thing back and forth for resurfacing. They leave it always in a resurfacing position, and they could still cut their seats because the digital level gives you that flexibility. So they can cut their seats, surface it, and if they want to correct the intake side, they can flip it up and level that off and cut that too. That's just a little whatever. All right, so I already cut this one seat. So factory seat on an intake on an AMC is a 30-degree seat. So this one has, I'm cutting 40-degree seat, 45-degree seat. This one still has a 30-degree seat. It's still getting some balance, but most of the time it sticks. This one I already cut. I already cut that to 45, and I did a concentricity test, and it's about a half a thou. See around. So you got the cylinder head up there. You tighten it up. You got you're standing relatively where you want it. You're going to take the level. First, what I do is I use this slot in the driver as an eyeball, quick eyeball on center. So if you're down here, say you're on an intake, I'm coming over to this intake, for example. I have a power feed on my X, I have a power feed on my Z, and it works well. So you can use, like I said, that peep slot for a quick kind of visual, get you close to center. And if you were way off this way, same thing. You can bring it back and just kind of get a quick eyeball to center. Again, there's no tool changes. You're just going to have your socket up in there, and you're going to be leveling and cutting. Because you don't need to find center with a coaxial. You're done. We've already established zeros. We've already established mechanical stick out and a mechanical center. And I've got my level and my center finder dialed in to bring me back to those positions. So I'm close to center, and I'm going to set this on the x-axis. I always adjust the x-axis first because if I had the y-axis tightened up and I needed to move the x, I got this support stand. It's common sense. I got the support stand. You're stuck. So I always do the x-axis. I loosen that up a little bit. Very simple. 9/16 on the ends, 3/4 on everything else. 9/16 and 1/2 inch, like the 13 millimeter. Very few different things. But the support stand, everything's 3/4 inch. The ends is 9/16. So it's pretty simple. You don't need a ton of stuff to adjust anything on this. So I'm on my X. I'm not at the number I want. Like I told you, my established number to find it, to get me back to my stick out that I mechanically determined to be, found my 0, is at 2.457, and it changes 7878. 2.4577878. I'm at 2.460. So I need to move this way. I've been setting these levels up, so if you tip it this way, you're going to hit a lower number. If you move it up that way, the number's going to go up. Initially, I wasn't doing that, but lately, it sort of made sense to me to do it that. So if you buy one from me now, that's how it's going to work. So I have you can't see it because the cylinder head's on here. I have just basically a 1/2 inch 13 nut with a bolt with a nut to lock it over here. And what I used to use a 3/4 socket as a lever, but I kind of found over time that I just tap it around with a mallet. So I can tap it up by hitting the bolt. I can tap it down by hitting the top of the plate or the bolt, whatever. So I need to come to so I'm up here. I need to come to my number is a 57.8. So basically, like I said, you just tap it around. You need to come up a little bit, and then when I already had it loose, and you lock it, make sure your number is staying, and it is. Because sometimes if you lock it, if it moves a little, but usually it stays. So now I'm looking for 2.4 5960s. 5960 is going to change, and I'm at 2.451. So it's got to go up. I just know that. You'll learn that over time. So what I do is I have on my stands, what I do, and is how I'm going to ship you some threaded rods. I give you a couple threaded rods cut to length. Basically that length and this length, just essentially. And because that's what I found that gives me, plus I'm going to give you a 1 foot long piece. And you can cut it to whatever, if you need something else, an extra. You can cut it to length, these lengths is what I found that I've used the most, so that's what I give you, those 2 lengths and an extra piece for you to cut if you run into something else. You're going to get all the mounting hardware. You're going to get this 1/2 inch studs and nuts and T-nuts and basically everything to put this thing on your mill and set it up and get it going. The hardware to mount the heads. You're going to get a couple spacers. For certain heads, late model Hemi, sometimes it'll mount up on the fixture plate, but it'll put kind of a, it won't, the stud is kind of bound a little bit, and I don't like pulling on a stud like that, so I give you spacers for certain heads so you can put a nice straight pull on the stud as you tighten it up the head to the plate. And that's what you get. So basically to adjust this axis here, I'm just going to raise it up until I hit my number. Like I said, 5960. And that's it. So just that easy. I have a dead nut stick out. I know I do because I've tested it I check it once in a while. And actually I just checked it again yesterday and it didn't even have a 10th. I checked the X and the Y, it wasn't even a 10th out. It was a dead nut 0 top to bottom. So that's that. Find center. Like I said, you put this thing up here. Now what I do is I made a little scribe mark on my socket, so I put it in the same position every time. I put this thing in the same position every time. Every time I put this up on a cylinder head, I put it this way always for the X and this way always for the Y. You can do it the other way if you're left-handed. I'm not, and for me that's more comfortable, but oh, every time X, X, Y, X, Y. So be consistent with whatever you do, and everything consistently. So like I said, I eyeballed center on this one, and I'm a little off because I can see it ain't gonna fit in there. I'm gonna crash. So basically, you just move it around until you can get the thing in the hole, and you put it in the hole. And now I gotta hit my zeros. So I'm gonna move my X, or this is my Y, and then I would lock the table. I'm gonna move my X, so I hit the 0 of my dial indicator, recheck it, everything looks good. And just that easy, I'm on center. So I'm leveling on center and I'm ready to cut a seat. So I got my bounce spring, and that little top piece there, the ball head in there. And you could always, you know, in the beginning you're not going to trust anything, so, but there's, I mean, it's perfectly, there's no deflection, it's perfect. So I'm going to put it first in low gear. I got it turned down, I'll turn it up a little bit. And I'm just going to bring the seat in, just like you would a seat and guide machine. So at this point, you're just going to cut your seat. Every valve job I do pretty much is I'm going to be doing a bolt cut, a chamber cut, a seat. I hardly ever do cylinder heads where it's just a valve job and just a regular get it back going down the street. I'm usually doing something competition. Everything is pretty much a competition valve job. So I would normally come in with a bolt cut and a chamber cut and a seat cut. But right now I'm bringing a 5-angle seat cutter in, and I'm just going to bring it in until the seat's in. I ain't messing around with anything else. This is just to show you how user-friendly, how easy everything works, and how this is the best thing out there. There's nothing even out there like this. If sweeping that pilot for every hole is a nightmare. You want to hang yourself after a while. I did it for 2 years, believe it or not. And after I started developing this stuff, I was like, I can't believe I didn't do something early. I was about ready to get a seat and guide machine, and so one thing led to another, and here I am. Now I wouldn't even think about getting a seat and guide machine. And especially it's $300 delivered in the USA for everything. You can't beat it. It's going to cost money for tooling. I got a bunch of tooling. I got like 8 ball heads. I developed a bunch of cutters. I got a ton of money into cutters and tooling and pilots and all that stuff. But for, if you have an old mill, put this on it. Let's get some decent amount of tooling. I don't know, maybe a couple thousand in tooling, and you can have a really nice setup. Anyway, so I'll finish cutting the seat. Looks like it's in. This guy is kind of jacked up. Now, bounce test is not, this guide is still, like I said, this thing's been shot blasted, and all I did was take a hone real quick, and a diamond hone real quick just to clean up the valve, wouldn't even go in it. And this is some old valve I had, so it's hanging up a little bit, but if it's bouncing, it's a good indication that you got a decent seat, and it's bouncing pretty good, even with a valve with a guide that sticks a little bit. You're going to want to set up a seat concentricity gauge, but I've done this before. I know that I'm not going to move the camera around at all. I'm just doing a quick demonstration, just to put a quick video out there. I do have a video out there where I did cut a seat, and I did do a concentricity test, and you can look at that. But I know these consistently thaw or less. Usually on iron heads where they're, it's kind of a softer material, and these are all high-speed steel pilots. Couple tenths, 0 to a couple tenths. I mean, just a couple tenths, it barely moves when you spin the gauge around. So always less than a thou. That's with high-speed steel. But that's basically it. If you want to go to another hole, you just basically stick it in. You move your pilot just like anything else. Like I said, you can just go over here, you eyeball it on center. You already know you're on center that way because you just found center on that way. You eyeball it on center. You come here, you adjust the X, you adjust the Y. You put this thing up here, you center it up. Easy as that. You cut your seat and move to the next hole. I've gotten to the point with practice, center finders, probably a year ago maybe, something like that, I made that up. After I had a little bit of practice with that, I can cut a seat, if I'm just, say, doing a valve job, just doing a seat cut a seat, move to the next hole, level off beyond center, and ready to cut a seat in about a minute and a half at the most. So there's nothing out there for a seat and guide machine that's going to be that quick and that accurate, consistent. Things always consistent. This thing's always consistent. That thing's pretty consistent too. It's just dial indicators. I mean, it's, it takes a little while to make it up. It's a little complicated. That thing's expensive because of components and all that. But it works good. And then if you want to use this as a milling machine, you just undo 2 9/16 here, 2 9/16 here. The whole center section comes off the mill, and you got your whole mill table less, 8 inches of real estate, 4 inches wide between the two of them, 5, So you still got essentially your whole milling table, or enough of it to where I haven't found where I needed more room. And then you just put your bar back up there and you tighten it back up, and away you go when you want to do cylinder heads or a mill or a manifold or whatever. So anyway, that was just a quick video. And I guess if you have any more questions, you can contact me. I just kind of went through it. I'm not doing more takes or anything. Just kind of a one and done video. I mentioned recently on a Speed Talk forum that what I had, and I just kind of wanted to put this out there to sort of quick demonstration of what I had and how it is what I say it is. But if you have any questions, you can get a hold of me. The thing works great, and for the money, you can't beat it. So that's about it.